Tonight, we roll into the world of the American semi-truck. These giants of asphalt and diesel, these cathedral-sized machines that thunder through the night carrying everything civilization needs to survive. From the hum of their massive engines to the hiss of their air brakes releasing at dawn-lit truck stops, semi-trucks are not just vehicles. They are the lifeblood of a nation, the silent pulse beneath every highway, the reason your morning coffee made it to the shelf and your Amazon package arrived on time. There is something almost mythical about an 18-wheeler when you see one cresting a hill at sunrise, chrome glinting, exhaust stacks cutting twin lines against the pink sky. They move through our landscape like ships across an ocean of concrete, captained by men and women who live between the white lines, who know every rest stop from Seattle to Savannah, who measure their lives not in days but in miles logged and loads delivered. If you enjoy these explorations of the machinery that moves America, feel free to like and subscribe, or share a thought in the comments below. It helps others find their way here too, one traveler at a time. But for now, let us begin our journey through 100 facts about these magnificent machines, these iron workhorses that make modern life possible. The semi-truck was born from necessity at the turn of the 20th century, when a Scottish-American inventor named Alexander Winton faced a problem that would change transportation forever. Winton manufactured automobiles in Cleveland, Ohio, and had built a thriving business selling his horseless carriages. But there was a hitch. His customers, scattered across distant cities, needed their purchases delivered, and driving each car individually to its destination was inefficient and costly. In 1898, Winton created the world's first practical semi-truck. It was not called a semi-truck then. People referred to it as a horseless carriage hauler, a contraption that could carry vehicles behind a motorized tractor. The design was revolutionary in its simplicity. A powered front section, the tractor, pulled a separate wheeled platform, the trailer, which bore the load. This articulated design allowed the vehicle to navigate turns that would be impossible for a single rigid truck of the same length. The following year, in 1899, Winton sold his first manufactured semi-truck, and an industry was born. What began as a solution to one man's delivery problem would grow into a transportation network that now moves more than 70% of all freight in the United States. Every item in your home, every piece of food in your refrigerator, every component in your car, traveled at some point on the back of a truck descended from Winton's original design. For the semi-truck to truly come into its own, it needed an engine worthy of its potential. That engine arrived in the form of the diesel, a technological marvel that would redefine power, efficiency, and endurance on the road. Rudolf Diesel, a German engineer born in Paris in 1858, was driven by a vision of creating an engine more efficient than anything that existed. From his earliest days, Diesel was curious about how things worked, about the transformation of heat into motion, about the hidden mechanics of the physical world. While studying engineering in Munich, he became fascinated with thermodynamics, the science of energy transfer and transformation. In 1897, after years of work and setbacks, Rudolf Diesel successfully created the first compression ignition engine. Unlike gasoline engines, which relied on spark plugs to ignite fuel, Diesel's engine used the heat generated by compressing air to ignite the fuel mixture. This fundamental difference made diesel engines more efficient, more durable, and capable of producing enormous amounts of torque at low engine speeds. The diesel engine arrived in America through various pathways. In 1913, after Diesel's original patents expired, the Winton Gas Engine and Manufacturing Company developed the first diesel engine built in the United States. Other companies like Fairbanks Morse entered the field, producing semi-diesel engines that used a heated bulb chamber to ignite fuel. By the 1920s and 30s, diesel technology was advancing rapidly, and manufacturers began to recognize its potential for heavy trucks. The true marriage of diesel and semi-truck occurred in the 1930s. In 1932, Kenworth engineer Murray Aitken drew up plans for what would become one of the first factory-built diesel-powered semi-trucks, equipped with a Cummins diesel engine. This was a turning point. The diesel engine offered everything a long-haul trucker needed. It delivered massive torque, could run continuously for hundreds of thousands of miles, and consumed less fuel than gasoline engines. Plessy Cummins, founder of Cummins Engine Company in 1919, recognized early that Rudolf Diesel's invention would transform transportation. Using Cummins' patented direct injection design from 1921, the company adapted the diesel engine for automotive use, creating the Model F and later the Model U. In a famous publicity stunt, Cummins sent a truck equipped with a Model U diesel engine from New York City to Los Angeles. The journey was completed in just 97 hours of running time, a record-breaking achievement decades before the Interstate Highway System existed. This demonstration proved that diesel power was not just practical but revolutionary. By the 1960s, diesel engines had become the standard power source for commercial trucking. They were simply better suited to the task than gasoline engines. Where a gasoline engine might reach peak horsepower at 6,000 or 7,000 RPM, a diesel reached its peak power at just 600 to 700 RPM and could sustain that power up to 1,800 RPM. This low-end torque was perfect for moving heavy loads. It meant a truck could get rolling from a standstill, climb steep grades, and maintain highway speeds without screaming the engine to its red line. When you stand beside a modern semi-truck and listen to its engine idle, you are hearing something fundamentally different from the engine in your car. Semi-truck engines are not about speed. They are about power delivered at low revolutions, about the ability to turn 80,000 pounds of truck and cargo into forward motion on a steep mountain grade. The average semi-truck engine today produces between 400 and 600 horsepower. To put that in perspective, a compact car might make 100 to 200 horsepower, while a high-performance sports car could reach 400 or 500. But horsepower, though impressive, is not the real story. The real story is torque. Torque is rotational force, the twisting power an engine can exert. It is what allows wheels to turn when burdened with weight, what gets a fully loaded truck rolling from a dead stop, what pulls a rig up a 6% grade without slowing. Modern semi-truck engines produce between 1,000 and 2,000 pound-feet of torque. Some specialized heavy-haul engines can reach 2,100 pound-feet or more. Compare this to a compact car, which might produce 100 to 200 pound-feet of torque, and you begin to understand the scale of difference. A semi-truck engine generates roughly 10 times the twisting force of a passenger vehicle. This is why 18-wheelers can haul loads that would simply overwhelm any consumer vehicle, why they can climb mountain passes that would leave a sedan stranded, why they can accelerate a fully loaded trailer from 0 to highway speed without drama. The largest semi-truck engines displace 15 to 16 liters. That is nearly 16,000 cubic centimeters of swept volume, compared to perhaps 2 to 3 liters in a typical car. These engines weigh between 2,500 and 3,000 pounds, nearly 10 times heavier than a car engine. They hold 15 gallons or more of oil, compared to 4 to 6 quarts in a passenger car. Everything about them is scaled to a different realm of power and endurance. Engine manufacturers like Cummins, Detroit Diesel, Packard, Volvo, and Caterpillar have spent decades refining these power plants. The Cummins X15, for instance, is a 14.9-liter inline-six engine that produces up to 605 horsepower and 2,100 pound-feet of torque. It is used in iconic trucks like the Freightliner Cascadia, the International LT Series, the Kenworth T880, and the Peterbilt 579. These engines are designed to run continuously, to log 1,000,000 miles or more before major overhaul, to operate day and night without complaint. Diesel engines achieve this remarkable longevity through their fundamental design. Because diesel fuel ignites through compression rather than spark, diesel engines are built with heavier, more robust components to withstand the higher pressures involved. Cylinder blocks are thicker, connecting rods are stronger, crankshafts are more massive. This overbuilt construction means diesel engines can endure far more stress and heat than their gasoline counterparts. Where a gasoline car engine might be celebrated for reaching 175,000 miles, a semi-truck diesel engine is just getting warmed up. 500,000 miles is routine. 800,000 miles is achievable with proper maintenance. Some engines, meticulously cared for, have exceeded 1 million miles in service, still running strong, still pulling loads across the American landscape. This endurance is not accidental. It is the result of engineering that prioritizes reliability over everything else. A semi-truck owner-operator cannot afford frequent breakdowns. Downtime means lost income, missed deliveries, unhappy customers. The diesel engine, with its simple, robust architecture, offers the reliability that the industry demands. If the engine is the heart of a semi-truck, the transmission is its brain, the sophisticated system that translates raw power into usable motion. And unlike the automatic transmissions in most cars, semi-truck transmissions are marvels of mechanical complexity, offering a range of gears that can seem bewildering to the uninitiated. A typical semi-truck has between 9 and 18 forward gears. The most common configurations are 10, 13, or 18 speeds. To put this in perspective, your car probably has 5 or 6 gears. Why does a truck need 3 times as many? The answer lies in the need to keep the engine operating within its optimal power band, across a wide range of speeds and loads. Remember, diesel engines produce their best power and efficiency at relatively low RPM. A truck driver needs to be able to start from a complete stop with 80,000 pounds of weight, accelerate smoothly through city traffic, climb mountain grades without losing momentum, and cruise efficiently at highway speeds. Each of these tasks requires a different gear ratio. In the lowest gears, the transmission multiplies engine torque enormously, allowing the truck to overcome inertia and get rolling. As speed builds, the driver shifts through progressively higher gears, each one allowing the wheels to turn faster relative to the engine's RPM. By the time the truck reaches cruising speed on the interstate, the transmission has placed the engine in a tall gear that allows high road speed while keeping engine RPM low, maximizing fuel efficiency. The gears are arranged in creative ways. Some transmissions use a splitter system, which effectively doubles the number of gears by offering high and low versions of each gear position. Others use a range system, which provides a low range for heavy pulling and a high range for highway cruising. The most complex transmissions combine both splitter and range systems, creating transmissions with 16 or 18 speeds. Operating these transmissions traditionally required skill and timing. Drivers learned to double clutch, a technique where the clutch is pressed twice during each shift to match engine speed to transmission speed, ensuring smooth gear changes. They learned to feel the truck, to sense when it was time to shift up or down, to read the terrain ahead and select the right gear for the climb or descent to come. In recent years, automated manual transmissions have become increasingly common. These systems retain the mechanical simplicity and efficiency of a manual gearbox, but use computers and actuators to handle the clutch and shift operations. The driver selects drive, and the computer does the rest, monitoring engine load, road speed, and throttle input to choose the optimal gear and execute shifts with precision. This reduces driver fatigue, improves fuel economy, and makes trucks more accessible to new drivers who may not have mastered the art of double clutching. Yet even with automation, the fundamental purpose remains the same. The transmission exists to keep the engine happy, to ensure that whether the truck is crawling up a Wyoming mountain pass or cruising through the Kansas flatlands, The diesel is spinning at its sweet spot, delivering power efficiently and reliably. Moving 80,000 pounds down the highway is impressive. Stopping 80,000 pounds safely is essential. This is where air brakes come into play, a technology so effective and reliable that it has been the standard for heavy trucks for nearly a century. Air brakes were invented by George Westinghouse in 1869 for use in railway trains. Westinghouse recognized that hydraulic brakes, which use pressurized fluid to apply braking force, were inadequate for trains and would later prove inadequate for heavy trucks. Fluid can leak, fluid lines can rupture, and when they do, braking power disappears, leaving a multi-ton vehicle unable to stop. Air brakes operate on a different principle, one that is both simple and ingenious. Compressed air is constantly generated by an air compressor driven by the truck's engine. This compressed air is stored in large tanks, called air reservoirs, located beneath the truck. When the driver presses the brake pedal, valves release compressed air from the reservoirs into brake chambers at each wheel. Inside each brake chamber, the compressed air pushes against a diaphragm, which in turn pushes a rod connected to an S-cam. The S-cam rotates, forcing brake shoes outward against the inside of a brake drum, creating friction that slows the wheel. When the driver releases the brake pedal, the air is vented back into the atmosphere. Springs pull the brake shoes away from the drum, and the wheel is free to turn again. This cycle happens thousands of times a day, reliably, predictably, powerfully. The beauty of air brakes is their fail-safe nature. If an air line ruptures or a component fails, the system does not simply lose braking power. Instead, the parking brakes, which are held off by air pressure, automatically engage. This is the opposite of hydraulic systems, where a loss of pressure means a loss of braking. With air brakes, a loss of pressure means the brakes lock on, bringing the truck to a halt. It is a design that prioritizes safety above all else. Modern semi-trucks operate their air brake systems at approximately 100 to 120 psi. The system includes multiple safety features. A pressure gauge in the cab shows the driver the current air pressure, ensuring they know the system is charged and ready. If pressure drops below 65 psi, warning lights and buzzers alert the driver. If pressure continues to fall, reaching 20 to 45 psi, the spring brakes automatically apply, bringing the truck to a controlled stop. There is also a slight delay inherent in air brake systems, known as brake lag. When the driver presses the pedal, it takes about half a second or more for compressed air to flow through the lines from the reservoirs to the brake chambers. This is longer than the nearly instantaneous response of hydraulic brakes in a car, and it means truck drivers must plan their stops farther in advance. At 55 miles per hour, brake lag adds about 32 feet to the stopping distance. Combined with perception distance, reaction distance, and actual braking distance, a fully loaded semi-truck traveling at 55 miles per hour can require more than 450 feet to come to a complete stop. This is why tailgating a semi-truck is so dangerous. The truck cannot stop as quickly as a car. Its immense mass, even with powerful brakes, requires time and distance to dissipate momentum. Drivers of semi-trucks are acutely aware of this, constantly scanning the road ahead, anticipating traffic changes, leaving space cushions around their vehicles. They know that their ability to stop is both their greatest responsibility and their greatest vulnerability. The hiss you hear when a semi-truck pulls into a truck stop and comes to a halt is the sound of those air brakes releasing, compressed air venting into the atmosphere. It is a sound that has become synonymous with the trucking life, a punctuation mark at the end of a long drive, a sigh of relief from a machine that has done its job once again. In the early days of trucking, drivers had no place to sleep in their vehicles. Long-haul routes were grueling ordeals. Drivers would pull over to the side of the road and try to rest sitting upright in their seats, or they would pay for cheap motel rooms, eating into their already meager earnings. Fatigue was endemic, accidents were common, and the life of a trucker was harder than it needed to be. Everything changed in 1933 when Kenworth became the first manufacturer to offer a factory-built sleeper cab. This was a compartment attached directly behind the driver's cab, where a driver could lie down flat and actually sleep. It seems like such a simple innovation, but it transformed the industry. The earliest sleeper cabs were rudimentary, barely more than coffin-sized boxes. Some were external compartments, accessed from outside the truck, with no connection to the driver's cab. These were called coffin sleepers, and the name was grimly appropriate. They were cramped, cold, uncomfortable, and dangerous. If an accident occurred, the person sleeping in the coffin sleeper had no escape route. By the 1940s and 50s, sleeper cabs began to be integrated into the truck's cab structure, allowing the driver to move between the driving position and the sleeping area without leaving the vehicle. Freightliner introduced the first overhead sleeper cab in 1953, though these early models were still quite small, often just 18 to 24 inches wide. Over the decades, sleeper cabs grew larger and more comfortable. By the 1970s and 80s, manufacturers were offering mid-sized sleepers with enough room for a proper bed, storage compartments, and basic amenities. By the 1990s, the modern full-size sleeper cab had arrived, complete with beds, small refrigerators, televisions, and ample storage. Today's sleeper cabs are essentially mobile apartments. High-end models can include full-size mattresses, microwaves, mini fridges, flat-screen televisions, climate control separate from the main cab, power outlets for laptops and phones, LED lighting, and even small bathrooms. Custom sleepers built by specialty companies can rival luxury RVs in their appointments, with hardwood cabinets, leather upholstery, satellite TV, and queen-size beds. The development of the sleeper cab had profound effects on the trucking industry. It allowed team driving, where two drivers alternate between driving and sleeping, enabling a truck to cover twice the distance in the same amount of time. It improved driver retention, as truckers could live on the road for weeks or months at a time in relative comfort. It enhanced safety, as drivers had a proper place to rest and were less likely to push themselves beyond exhaustion. For the driver, the sleeper cab became a sanctuary. It is where you retreat after a long day battling traffic and weather, where you eat your meals, read your books, call your family, and catch a few hours of rest before the next shift begins. It is personal space in an impersonal industry, a few square feet of home in a life spent far from home. Regulations now mandate rest periods for commercial truck drivers. Hours of service rules limit how many hours a driver can be on duty and require specific rest breaks. The sleeper cab makes these regulations practical. Without it, drivers would be forced to stop at motels or rest areas, adding expense and complexity to every trip. With it, the road becomes livable, the journey sustainable. There are strict limits to how much weight a semi-truck can carry, and these limits exist for good reason. Roads and bridges are engineered to withstand certain loads. Exceed those loads and infrastructure crumbles. Tires fail, brakes overheat, accidents happen. At the federal level, the maximum gross vehicle weight for a semi-truck on interstate highways is 80,000 pounds. This includes the weight of the tractor, the trailer, and the cargo combined. It is not 80,000 pounds of cargo. It is 80,000 pounds total. The weight of the tractor itself, depending on whether it is a day cab or a sleeper, and depending on the size of the fuel tanks and other equipment, typically ranges from 10,000 to 25,000 pounds. The trailer, when empty, weighs about 10,000 to 14,000 pounds for a standard 53-foot dry van. This means that the actual cargo capacity is often somewhere between 43,000 and 48,000 pounds, depending on the specific configuration of the truck and trailer. But the 80,000-pound limit is not the only constraint. There are also axle weight limits. A single axle, like the steer axle at the front of the truck, is typically limited to 12,000 pounds. The drive axles, usually configured as a tandem pair, are limited to a combined 34,000 pounds. The trailer axles, also typically a tandem configuration, are similarly limited to 34,000 pounds. This means that even if a truck's total weight is below 80,000 pounds, if too much weight is concentrated on one set of axles, it is still illegal and unsafe. Properly distributing weight across all axles is a skill that freight loaders and truck drivers must master. Improper weight distribution can cause handling problems, tire blowouts, brake failures, and damage to roadways. Weigh stations are scattered along interstate highways to enforce these regulations. Trucks over 10,000 pounds gross weight are required to stop at open weigh stations. There, the truck is driven onto a scale, and officials check that the total weight and axle weights are within legal limits. Violators face fines that can range from a few $100s to thousands of dollars, depending on how much the truck is overweight and the laws of the particular state. Some states have stricter limits than federal law. Some allow higher weights on certain roads with special permits. Oversized and overweight loads, such as those carrying construction equipment or industrial machinery, require special permits and often must travel with escort vehicles and follow specific routes. The 80,000-pound limit is a compromise between capacity and infrastructure protection. Heavier trucks would be more efficient, able to carry more freight per trip, but they would also cause exponentially more damage to roads and bridges, which deteriorate according to the fourth power of axle weight. Doubling the weight on an axle increases road damage by a factor of 16. This is why maintaining weight limits is critical to preserving the infrastructure that the trucking industry depends on. For the driver, weight is a constant consideration. Before every trip, the load must be verified. During the trip, drivers must be aware of which states they will pass through and what their specific regulations are. At weigh stations, they must hope that the load was properly distributed and that nothing has shifted in transit. Overweight tickets are expensive and can result in the truck being held until another truck arrives to offload the excess weight, costing time, money, and reputation. We have touched on the diesel engine already, but it is worth exploring more deeply why diesel fuel and diesel engines are so dominant in the trucking world. The reasons are rooted in chemistry, thermodynamics, and economics. Diesel fuel contains about 10 to 15% more energy per gallon than gasoline. This is because diesel is a heavier, denser fuel with more hydrocarbon chains per unit volume. When burned, it releases more energy. This higher energy content translates directly into better fuel efficiency. A semi-truck can travel up to 30% farther on a gallon of diesel than it could on a gallon of gasoline, assuming engines of similar design. But fuel efficiency is not just about energy content. It is also about how efficiently the engine converts that energy into motion. Diesel engines operate on what is called the diesel cycle, which involves compressing air to such high pressure and temperature that diesel fuel injected into the combustion chamber spontaneously ignites. This compression ignition is more efficient than the spark ignition used in gasoline engines. Diesel engines typically achieve thermal efficiencies of around 40 to 45%, meaning that 40 to 45% of the energy in the fuel is converted into useful work. Gasoline engines, by contrast, typically achieve around 25 to 30% thermal efficiency. The high compression ratios in diesel engines, often 16:1 or higher compared to 10:1 in gasoline engines, contribute to this efficiency. Higher compression means more complete combustion and better extraction of energy from the fuel. Diesel engines also produce prodigious amounts of torque at low engine speeds. This is because diesel fuel burns more slowly than gasoline, creating a longer, more sustained push on the piston. This characteristic is perfect for heavy hauling. A truck needs torque to overcome inertia, to accelerate a heavy load, to climb grades. Horsepower, which is a measure of how quickly work is done, matters less in trucking than raw pulling power. Diesel engines are also built to run continuously. While a gasoline car engine might be shut off every time the car is parked, diesel truck engines are often left idling for hours. They idle at truck stops to power climate control in the sleeper cab, to keep oil warm in cold climates, to run auxiliary equipment like refrigeration units on reefer trailers. Diesel engines handle this continuous operation without complaint, because their heavy-duty construction and lower operating speeds mean less wear and tear. There are environmental considerations as well. Historically, diesel engines were criticized for producing more nitrogen oxides and particulate matter than gasoline engines. But modern diesel technology has addressed these concerns. Advanced emission control systems, including diesel particulate filters and selective catalytic reduction systems that inject urea into the exhaust stream, have made diesel engines remarkably clean. The Environmental Protection Agency has reduced allowable sulfur levels in diesel fuel to 15 parts per million, further reducing emissions. Economically, diesel also makes sense for long-haul trucking. Although diesel fuel prices fluctuate and sometimes exceed gasoline prices at the pump, the superior fuel efficiency of diesel engines means lower overall fuel costs per mile. For an industry where fuel is one of the largest operating expenses, this advantage is significant. The articulated design of a semi-truck, the feature that gives it its name, depends on a critical connection point called the fifth wheel. This is the large, round coupling plate mounted on the rear of the tractor, above the drive axles. It is called a fifth wheel because early carriages had 4 wheels, and adding this pivoting coupling mechanism was like adding a fifth wheel to the vehicle. The fifth wheel on the tractor locks onto the kingpin, a large metal pin extending downward from the front of the trailer. When the truck backs beneath the trailer and the fifth wheel slides under the trailer's front plate, the kingpin drops into the locking jaws of the fifth wheel with a satisfying clunk. This connection is what holds the tractor and trailer together, yet allows them to pivot relative to each other, enabling the truck to make turns. The fifth wheel is designed to bear enormous weight. The entire weight of the loaded trailer presses down on this coupling. It must also withstand the forces of acceleration and braking, which try to push the trailer forward or pull it backward relative to the tractor. High-strength steel and precision engineering ensure that the fifth wheel can handle these stresses reliably. Locking and unlocking the fifth wheel is a routine part of a trucker's day. To couple a trailer, the driver backs the tractor under the trailer's nose, aligning the fifth wheel with the kingpin. As the tractor continues to back up, the fifth wheel engages the kingpin, and locking jaws snap shut, securing the connection. The driver then connects the air lines and electrical connections between tractor and trailer, raises the trailer's landing gear, and performs a tug test, pulling forward gently to ensure the fifth wheel is properly locked. To uncouple, the process is reversed. The driver lowers the trailer's landing gear to support the trailer's weight, disconnects the air and electrical lines, pulls a release handle that opens the fifth wheel's locking jaws, and pulls the tractor forward out from under the trailer. The trailer remains standing on its landing gear, ready for the next tractor to pick it up. This ability to quickly connect and disconnect trailers is one of the great advantages of the semi-truck design. A single tractor can pull many different trailers over the course of a week. Drop-and hook operations, where a driver drops off a loaded trailer and immediately hooks to a preloaded trailer waiting at the same location, minimize downtime and maximize efficiency. The tractor stays in motion, generating revenue, while trailers are loaded and unloaded independently. The kingpin itself is a precisely machined component, typically 2 or 3.5 inches in diameter, made of hardened steel. It must be strong enough to bear the trailer's weight and endure the constant articulation forces without bending or breaking. Inspecting the kingpin for wear, cracks, or damage is part of regular maintenance. A failed kingpin can lead to a trailer separation, a catastrophic event where the trailer breaks free from the tractor while moving. The modern trucking industry would not exist without the Interstate Highway System. Before the interstates, freight traveled on a patchwork of state and local roads, many of them two-lane, poorly maintained, and ill-suited to heavy trucks. Long-distance trucking was slow, expensive, and unreliable. Everything changed with the Federal Aid Highway Act of 1956, signed by President Dwight D. Eisenhower. This legislation authorized the construction of 41,000 miles of high-speed, limited-access highways connecting major cities and regions across the United States. It was the largest public works project in American history, and it fundamentally reshaped the nation's economy and geography. For trucking, the interstates were a godsend. Suddenly, trucks could travel from coast to coast on smooth, straight, high-speed roads designed specifically for heavy vehicles. Travel times plummeted, costs fell, reliability improved. The interstate system made long-haul trucking not just feasible, but dominant. The Highway Act itself was influenced by the needs of trucking and national defense. Eisenhower had seen the German Autobahn during World War II and recognized the strategic value of a modern highway network. In the event of war or national emergency, the interstates would allow rapid movement of military equipment and personnel. In peacetime, they would supercharge commerce. By the 1970s, the interstate network was largely complete, and trucking had firmly established itself as the primary mode of freight transport in America. Railroads, which had dominated freight for a century, saw their market share steadily eroded by trucks that could deliver goods door to door, on flexible schedules, without the need for rail yards and transfer points. Today, the Interstate Highway System comprises more than 46,000 miles of roads, and trucks account for an enormous percentage of the traffic on these routes. On some stretches, particularly through major freight corridors, trucks can make up 30 or 40% of all vehicles. The highways have become the arteries of the American economy, and trucks are the blood cells, constantly circulating, delivering oxygen in the form of goods and materials to every corner of the nation. Behind every semi-truck is a human being, and the life of a truck driver is unlike any other profession. It is a life of solitude and constant motion, of long hours and irregular schedules, of seeing the country from behind a windshield while rarely having time to stop and explore. The average truck driver covers 2,000 to 3,000 miles per week. Some weeks, especially for long-haul drivers, can see mileage climb even higher. This is life on the road, sleeping in the truck sleeper cab, eating at truck stops and fast food restaurants, showering in truck stop facilities, calling home on a cell phone from a rest area somewhere between everywhere and nowhere. Hours of service regulations, enforced by the Federal Motor Carrier Safety Administration, limit how long drivers can be on duty. Currently, a driver can drive a maximum of 11 hours after 10 consecutive hours off duty. The driver cannot drive beyond the 14th hour after coming on duty, and the driver must take a 30-minute break after 8 hours of driving. Over a rolling 7 or 8-day period, a driver cannot exceed 60 or 70 hours of on-duty time. These rules are meant to combat driver fatigue, which has been a factor in countless accidents. Electronic logging devices, now mandatory in all commercial trucks, automatically track driving time and enforce compliance, making it nearly impossible for drivers to fudge their logbooks as some did in the past. The work is hard on the body. Sitting for long hours, eating poorly, lacking exercise, these all take a toll. The work is hard on relationships. Drivers may be away from home for weeks at a time, missing birthdays, anniversaries, school events, the small daily moments that make up a family life. Yet many drivers love the work. There is freedom in it, a sense of independence that few jobs offer. You are your own boss on the road. You decide when to stop for fuel, when to take a break, which route to take when there are alternatives. You see the country in a way few people do, watching sunrises over the Appalachians, sunsets over the Great Plains, storms rolling across the Texas sky. There is also pride in the work. Truck drivers know they are essential. They know that without them, grocery stores would empty within days, factories would shut down for lack of parts, hospitals would run out of supplies. They are the invisible infrastructure, the people who make modern life possible, and they carry that knowledge with them every mile. The trucking industry faces a persistent driver shortage. As experienced drivers retire, there are not enough new drivers entering the field to replace them. The work is demanding. The pay, while decent, is not always commensurate with the sacrifices required, and the lifestyle does not appeal to everyone. Companies are offering higher wages, better benefits, and more home time to attract and retain drivers, but the shortage persists. For those who do choose this life, it becomes a calling. You meet drivers who have logged millions of miles, who have been behind the wheel for 30 or 40 years, who cannot imagine doing anything else. They speak a language of highway numbers and truck stop names, of load weights and fuel mileage, of weather reports and road conditions. They are the knights of the modern age, piloting their steel steeds across a landscape of asphalt and diesel. The semi-truck of today is a far cry from the mechanical beasts of 50 years ago. Modern trucks are rolling computers, packed with sensors, cameras, and electronics that would have seemed like science fiction to earlier generations of drivers. Automated manual transmissions, as mentioned, have largely replaced the traditional stick shift in new trucks. These systems use electronic control units to monitor dozens of inputs: road speed, engine RPM, throttle position, vehicle weight, and select the optimal gear for current conditions. Shifts are executed by pneumatic or electric actuators with a precision no human driver could match. Electronic stability control systems, now mandatory on all new trucks and trailers, use wheel speed sensors and yaw sensors to detect when a vehicle is beginning to lose control. If the system senses the onset of a jackknife or rollover, it can selectively apply brakes to individual wheels and reduce engine power to help the driver regain control. This technology has prevented countless accidents. Collision mitigation systems use radar and cameras to monitor the road ahead. If the truck is approaching another vehicle or obstacle too quickly, the system first warns the driver with visual and audible alerts. If the driver does not respond, the system can automatically apply the brakes to reduce speed or avoid a collision. Some advanced systems can bring the truck to a complete stop if necessary. Lane departure warning systems use cameras to track lane markings on the road. If the truck drifts out of its lane without the turn signal being activated, the system alerts the driver. Some systems can even apply gentle steering corrections to guide the truck back into its lane. Adaptive cruise control, similar to systems found in passenger cars, but adapted for the heavy-duty environment, uses radar to maintain a set following distance from the vehicle ahead. The truck automatically adjusts its speed to match traffic flow, reducing driver workload on long highway stretches. Telematics systems, connected to cellular networks, transmit real-time data from the truck to fleet managers. They can monitor fuel consumption, engine performance, driver behavior, location, and more. This data allows companies to optimize routes, identify maintenance needs before breakdowns occur, and coach drivers on improving efficiency and safety. Even the engines themselves are managed by sophisticated electronics. Modern diesel engines use electronic fuel injection systems, often common rail designs with injection pressures exceeding 30,000 psi. These systems can inject fuel multiple times per combustion cycle, with precise timing and quantities, to optimize power, efficiency, and emissions. Variable geometry turbochargers adjust boost levels based on engine load. Exhaust gas recirculation systems reduce nitrogen oxide emissions. Diesel particulate filters capture soot. Selective catalytic reduction systems inject urea to break down nitrogen oxides into harmless nitrogen and water. All of this technology makes trucks cleaner, safer, and more efficient than ever before. It also makes them more complex. Mechanics now need laptop computers and software diagnostic tools to work on trucks. Drivers need to understand the electronic systems in their vehicles and trust them to function correctly. Looking ahead, the industry is exploring even more advanced technologies. Electric semi-trucks like the Tesla Semi are beginning to enter service, offering zero emissions and lower operating costs, though challenges remain with charging infrastructure and range. Hydrogen fuel cell trucks are in development, offering the potential for long range and fast refueling. And autonomous driving technology, while still years away from full deployment in trucking, is advancing rapidly. Companies are testing self-driving trucks in controlled environments, and some limited autonomous operations, such as trucks operating on closed campuses or between nearby facilities, are already underway. For many owner-operators, a semi-truck is not just a tool. It is an expression of identity, a canvas for customization, a source of pride. The culture of truck customization is rich and vibrant, with entire industries built around making trucks look and perform the way their owners desire. Chrome is king in this world. Chrome bumpers, chrome exhaust stacks, chrome air cleaners, chrome fuel tanks, chrome wheels. The more chrome, the better. A well-chromed truck glints in the sunlight like a jewel, turning heads at truck stops and earning nods of respect from other drivers. Polishing chrome is a labor of love, a ritual performed at truck washes and rest areas, keeping the metal bright against the grime of the road. Custom paint jobs are another way owners personalize their trucks. Some opt for simple, elegant two-tone schemes. Others go all out with murals, flames, patriotic themes, or intricate airbrushed artwork. Truck shows, held across the country, feature competitions where the most elaborately customized trucks are displayed and judged. Winners receive trophies, prizes, and the admiration of their peers. Lighting is another popular customization. LED lights have made it easy and affordable to add accent lighting, cab lights, wheel well lights, and marker lights in every color imaginable. Some trucks are rolling light shows, with synchronized LED patterns that pulse and change color. Performance modifications are common as well. Upgraded turbochargers, performance tuning chips, high-flow air filters, and aftermarket exhaust systems can boost horsepower and torque. While these modifications can void warranties and may run afoul of emissions regulations, the allure of extra power is strong for some drivers. Interior modifications range from upgraded upholstery and custom dash panels to elaborate sleeper cab build-outs with hardwood trim, premium sound systems, and luxury bedding. For drivers who live in their trucks, these touches turn a cab into a home. There is also a practical side to customization. Aerodynamic fairings, trailer skirts, and cab extenders reduce drag and improve fuel economy, sometimes by as much as 10 to 15%. For an owner-operator running hundreds of thousands of miles a year, this can translate into tens of thousands of dollars in fuel savings. The culture extends beyond the truck itself. Trucking has its own music, its own slang, its own folklore. CB radio culture, though diminished from its 1970s heyday, still thrives in some regions. Drivers use handles or nicknames and communicate using a colorful lexicon. A bear is a police officer. A chicken coop is a way station. A parking lot is a truck traveling at high speed. The hammer lane is the left lane. And the phrase 10-4, good buddy, though cliched, still echoes across the airwaves. Truck stops have become community hubs, places where drivers gather not just to refuel and eat but to socialize, swap stories, and share information. Some truck stops have chapels, gyms, barber shops, and even movie theaters. The largest, like Iowa 80 along Interstate 80 in Iowa, are destinations in their own right, sprawling complexes covering acres and offering every service and product a driver might need. Let us talk numbers, the cold, hard statistics that define the scale and impact of trucking in America. These numbers tell a story of an industry so vast, so essential, that it is difficult to fully grasp. There are approximately 2 million semi-trucks registered in the United States. Roughly 1/3 of these are registered in just 3 states: California, Florida, and Texas. These states, with their large populations and economies, generate enormous freight demand. Semi-trucks move more than 70% of all freight tonnage in the United States. That is everything from raw materials to finished goods, from the food on grocery store shelves to the parts that keep factories running. In terms of value, trucking generates nearly $1 trillion in freight revenue annually. The average semi-truck travels approximately 100,000 miles per year. Some long-haul trucks easily exceed this, racking up 125,000 miles or more. Over a truck's working life, it can accumulate 1 million miles or more before being retired. Fuel is the single largest operating expense for trucking companies, often accounting for 25 to 30% of total costs. Fuel economy for a loaded semi-truck typically ranges from 6 to 7 miles per gallon. Though advances in aerodynamics, engine technology, and driving techniques have pushed some trucks into the 8 to 9 mpg range under optimal conditions. A fully loaded semi-truck requires significantly more stopping distance than a passenger vehicle. At 60 miles per hour, a loaded truck might need 500 feet or more to come to a complete stop. This is more than the length of a football field. At higher speeds, the distance increases further. This is why maintaining safe following distances and anticipating traffic changes are critical skills for truck drivers. The physical dimensions of a semi-truck are also worth noting. The average length of a tractor and 53-foot trailer combination is 70 to 75 feet. The width is 8.5 feet, the maximum allowed on most roads without special permits. The height is around 13.5 feet, though some trailers, particularly refrigerated units with tall boxes, can approach 14 feet. These dimensions mean that trucks cannot go everywhere cars can go. Low bridges, narrow streets, and tight turns can all present obstacles. While the tractor is the visible, powerful face of the semi-truck, the trailer is where the work gets done. There is a wide variety of trailer types, each designed for specific kinds of cargo. The dry van is the most common. It is a standard rectangular box trailer, typically 53 feet long, enclosed and weatherproof. Dry vans haul everything from boxed goods to furniture to electronics. They are the general-purpose workhorses of the industry. Refrigerated trailers, or reefers, are similar to dry vans, but equipped with refrigeration units that keep the cargo at a controlled temperature. Reefers haul perishable goods, food, pharmaceuticals, anything that must stay cold. The refrigeration unit runs continuously, powered by a small diesel engine or, when the truck is parked, by plugging into an electrical hookup. Flatbed trailers are open platforms with no sides or roof. They are used for cargo that is too large or awkwardly shaped to fit into an enclosed trailer, such as construction equipment, steel beams, lumber, or large machinery. Cargo on a flatbed must be secured with straps, chains, and binders, a process called tarping and securing, which requires skill and attention to detail. Step-deck trailers, also called drop-deck trailers, have a lower deck in the rear, allowing them to carry taller cargo than a standard flatbed while staying within legal height limits. Double-drop trailers go even lower, with a well section in the center that can accommodate extremely tall or heavy loads. Tank trailers, or tankers, are cylindrical tanks designed to carry liquids or gases. They haul everything from milk and juice to gasoline and chemicals. The tank's shape distributes weight efficiently and prevents sloshing, which can destabilize the vehicle. Hazmat tankers, carrying hazardous materials, are subject to strict regulations and require special endorsements on the driver's license. Lowboy trailers are specialized heavy-haul trailers with very low deck heights, designed to carry oversized and overweight loads like bulldozers, excavators, and industrial equipment. Lowboys often have detachable goosenecks, allowing the front of the trailer to be disconnected and lowered to the ground, creating a ramp for loading and unloading. Intermodal containers, the standard metal boxes used in international shipping, are often hauled on chassis trailers designed specifically to carry them. These trailers are simple skeletal frames with locking mechanisms to secure the container. Car haulers transport automobiles from factories to dealerships. They have multiple levels of ramps and decks, allowing them to carry 8 to 12 cars at a time. The trailers are carefully designed to maximize capacity while keeping the overall length, height, and weight within legal limits. Each trailer type requires different handling techniques and presents different challenges. A tanker's liquid cargo can slosh and create dynamic loads. A flatbed's cargo must be inspected and secured before every trip. A reefer's refrigeration unit must be maintained and fueled. A lowboy often requires special permits and escort vehicles. Mastering all these trailer types is a mark of a versatile, experienced driver. If you were to stop all trucking in America, the effects would be felt almost immediately. Within 24 hours, hospitals would begin to run short of medical supplies. Within 2 to 3 days, grocery stores would start to empty. Gas stations would run out of fuel. Within a week, the nation would be in crisis. This is not hyperbole. Studies conducted by the American Trucking Associations have modeled what would happen if the trucking industry were to shut down. The results are sobering. Our modern, just-in-time economy depends utterly on the continuous flow of goods by truck. Manufacturers operate with minimal inventory, relying on daily deliveries of parts and materials. Retailers stock their shelves with products that arrive on trucks multiple times per week. There is no buffer, no stockpile to fall back on. Trucking touches every aspect of life. The food you eat traveled on a truck. The clothes you wear arrived in stores via truck. The medicine in your cabinet was delivered by truck. The fuel in your car was hauled to the gas station by a tanker truck. The smartphone in your pocket, the computer you work on, the furniture in your home, all of it, at some point in the supply chain, rode on the back of a semi-truck. This dependence is both a strength and a vulnerability. It makes the economy efficient and responsive, but it also means disruptions in trucking ripple outward rapidly. Natural disasters, strikes, fuel shortages, anything that impedes the flow of trucks can have cascading effects. During the COVID-19 pandemic, the trucking industry faced unprecedented challenges. Demand surged for certain goods while collapsing for others. Drivers were hailed as essential workers, heroes who kept the country supplied while many others sheltered at home. The industry adapted, rerouted, and persevered, proving its resilience and importance. The semi-truck has come a long way from Alexander Winton's first horseless carriage hauler in 1898. It has evolved through diesel power, air brakes, sleeper cabs, interstate highways, and now electronic controls and advanced safety systems. But the evolution is not over. The trucks of tomorrow will be even more advanced, cleaner, safer, and perhaps fundamentally different. Electric trucks are no longer science fiction. The Tesla Semi, powered by batteries and electric motors instead of diesel, promises zero emissions, lower maintenance costs, and impressive performance. With a range of 300 to 500 miles on a single charge, and the ability to recharge to 80% in 30 minutes using Tesla's megacharger network. The Tesla Semi is beginning to prove that electric propulsion can work for long-haul trucking. Other manufacturers, including established players like Freightliner, Volvo, and Peterbilt, are also developing electric models. Hydrogen fuel cell trucks represent another path forward. They use hydrogen gas to generate electricity on board, which then powers electric motors. The only emission is water vapor. Refueling takes minutes, similar to diesel, and range can match or exceed diesel trucks. The challenge is building a hydrogen refueling infrastructure, but pilot programs are underway in California and Europe. Autonomous trucks, once the realm of fantasy, are inching closer to reality. Companies like Waymo, Too Simple, and Aurora are testing self-driving trucks on public highways, with safety drivers on board but the truck doing most of the driving. The technology uses LiDAR, radar, cameras, and advanced artificial intelligence to navigate roads, avoid obstacles, and follow traffic rules. The promise is increased safety, as computers do not get tired or distracted, and improved efficiency, as autonomous trucks could operate around the clock with minimal downtime. Full Level 5 autonomy, where the truck can handle all driving tasks in all conditions without human intervention, is still years away. But Level 4 autonomy, where the truck can drive itself on highways, while a human handles more complex maneuvers like city driving and docking, may arrive within the next decade. This would fundamentally change the role of the driver, shifting from operator to monitor, and raise complex questions about employment, regulation, and safety. Platooning is another technology being explored. This involves multiple trucks traveling closely together in a coordinated convoy, with the lead truck controlled by a human driver and the following trucks driving autonomously, mimicking the leader's movements. The close spacing reduces aerodynamic drag, improving fuel efficiency for all the trucks in the platoon. Alternative fuels, beyond electricity and hydrogen, are also being investigated. Renewable diesel, made from organic materials, can be used in existing diesel engines with little or no modification and offers lower carbon emissions. Natural gas, both compressed and liquefied, has been used in some truck fleets, offering cleaner combustion than diesel, though adoption has been limited by infrastructure and energy density concerns. Aerodynamics will continue to improve. Trailer side skirts, boat tails, and cab fairings are becoming standard, and more advanced designs, including active aerodynamic systems that adjust based on wind conditions, are being tested. Weight reduction through advanced materials, such as aluminum and composites, will allow trucks to carry more payload within the 80,000-pound limit, improving efficiency. Connected vehicles, communicating with each other and with infrastructure through vehicle-to-vehicle and vehicle-to-infrastructure networks, will enable better traffic management, safer merging, and more efficient routing. The future of trucking is being written now, in laboratories, test tracks, and on the roads themselves. It will be a future where trucks are cleaner, smarter, and safer, where the old diesel rumble might give way to the silent hum of electric motors, where drivers might become fleet managers overseeing autonomous vehicles from remote offices. Or perhaps the human element will remain, with technology augmenting rather than replacing the skill and judgment of the driver. One thing is certain: the semi-truck, in whatever form it takes, will remain essential. Goods must move, the economy must flow, and the highways will always need those who are willing to drive them. There is something undeniably romantic about the semi-truck, though it is a romance born not of softness, but of steel and distance and solitude. It is the romance of seeing new places, of watching the landscape change from the Rockies to the Midwest Plains to the Appalachian forests, all from the same driver's seat. It is the romance of independence, of being your own master on the road, responsible only for your load and your logbook and the white line ahead. It is also the romance of power, of commanding a machine so large and forceful that other vehicles scatter like leaves before it, of knowing that inside that engine block is enough torque to pull a house up a mountain. There is satisfaction in mastering such a machine, in executing a perfect shift, in backing a 53-foot trailer into a tight dock without touching the walls, in feeling the truck respond to your inputs as though it were an extension of your own body. For the truly committed, trucking becomes a way of seeing the world. You learn the country in a way tourists never do. You know which states have the best rest areas and which have the worst. You know where the speed traps are, which cities have the worst traffic, which truck stops serve the best food. You have favorite routes and hated routes. You have stories from every state, memories attached to exits and mile markers. You see sunrises that would make a poet weep, spreading gold and crimson across endless skies. You see storms rolling in from 100 miles away, lightning flickering like a distant war. You see the lights of cities appearing over the horizon like galaxies, and you see rural darkness so complete that the stars seem close enough to touch. You also see the hard side of America, the truck stops at 3 in the morning, the closed factories and abandoned towns, the evidence of poverty and decay that hides just off the interstate. You see accidents, the wreckage of lives interrupted, and you drive past knowing it could have been you. You see the toll the road takes on people, the drivers who have been out here too long, who have forgotten what home feels like. Yet many who enter this life stay in it. They become lifers, drivers with millions of miles under their belts, people who cannot imagine doing anything else. They speak with affection about their trucks, giving them names, talking to them as though they were companions. In a way, they are. When you spend 14 hours a day, 6 days a week in the same cab, the truck becomes more than metal and rubber. It becomes a partner. The end of a long haul, when you finally pull into the destination and shut down the engine and step out into the sudden silence, is a moment of release. Your back aches, your eyes burn, you are exhausted, but you have done it. You have moved the load across 1,000 miles of highway, overcome every obstacle, met the deadline. Tomorrow there will be another load, another road, another destination. But tonight you rest. And so we return to where we began, to the sight of a semi-truck cresting a hill at sunrise, chrome glinting, exhaust stacks cutting lines against the sky. These machines, these titans of the highway, are more than transportation. They are symbols of human ingenuity, of our ability to build tools that extend our reach and amplify our strength. From Alexander Winton's first crude hauler to the high-tech, computer-controlled rigs of today, the semi-truck has been refined and perfected over more than a century. Diesel engines that can run 1,000,000 miles, air brakes that can stop 80,000 pounds safely, again and again, transmissions with 18 gears to keep the engine in its perfect power band, sleeper cabs that turn a truck into a home. Every bolt, every gasket, every line of code in the electronic control unit exists for a reason. Every regulation, every weight limit, every hours of service rule is written in lessons learned, often at great cost. The trucking industry is vast and complex, shaped by engineering, economics, law, and the human need to move goods from one place to another. If you see a truck on the highway today, perhaps you will look at it differently now. Perhaps you will see not just a large vehicle taking up space, but a marvel of engineering, a node in the vast network that keeps the country running, a workplace, and sometimes a home for the driver inside. Perhaps you will remember that everything you own came to you, at least in part, on a truck, and that the driver who delivered it is one of millions who work unseen to make modern life possible. The semi-truck is a quiet giant, unassuming in its ubiquity, easy to overlook because it is so familiar. But peel back the layers, examine the systems, learn the history, and you discover something remarkable. You discover a machine that is as impressive as any spacecraft or supercomputer, a human achievement as significant as the railroad or the airplane, a legacy of innovation and determination that continues to roll forward every day on highways across the nation. And on those highways tonight and every night, thousands of drivers are out there, steering their rigs through the darkness, chasing deadlines, making deliveries, living the life that few understand and even fewer choose. They are the guardians of commerce, the knights of the modern age, and the roads they travel are the arteries of the world. So as you drift toward sleep tonight, Imagine the sound of a diesel engine throttling down at a distant truck stop, the hiss of air brakes releasing, the clunk of a fifth wheel locking onto a kingpin. Imagine the soft glow of dashboard lights in a sleeper cab, a driver checking the map for tomorrow's route, calculating miles and hours and fuel stops. Imagine the highway stretching endlessly forward, white lines flashing past, mile markers counting down the distance to home. The semi-truck rolls on, as it has for more than 100 years, as it will for years to come. Powerful, essential, unstoppable, a monument in motion to the human spirit and the open road. If you have enjoyed this journey down the American highways, I invite you to join me for the next one. There are 50 states to explore, each with its own stories, its own highways, its own place in the grand tapestry of this nation. Subscribe to Ride Along, and together we will discover the roads that connect us all. Until then, drive safe, and may the road rise up to meet you.